Hey, Things, what's up? It's Chris, founder of Things.com, and in today's video, real quick, I want to show you how to calculate the standard deviation of a Python list. So this is a common question on the blog, and therefore I decided to record a quick video to actually answer this question. Okay, so first things first, what is the standard deviation? So the standard deviation is simply the square root of the variance. The variance here noted as S to the power of 2. And what does it mean? Like the variance is actually like the how much. So if you have a certain number of data points and you have a mean value that you calculate as like this part here, this is the mean value, then it is like the average deviation of those data points from the mean value. So you can either have like data set that is like widely spread around the mean value, or you can have a very like data set that is really close, where the data points are really close to the mean value. So this is the standard deviation, and you calculate it with this formula. Sometimes, so some people would divide the number would divide it by n, which is like the number of observations in the data set, and some people divide it by n-2. This is actually called, let me quickly check, it's called the Bessel's correction. So sometimes they divide define standard deviation as like dividing it by the number of data points minus 1, or sometimes they divide it by simply n. That's why we get different results for some approaches. Okay, so how to do this in a Python list? So say we have the following Python list of some values. Now we can, like our first approach is to use NumPy. I would say this is also the simplest approach. So we import NumPy as np, and now we calculate the standard deviation as np.std, short for standard deviation, and we pass the list into the std function and print the result, right? So very simple. And if we do this, like this is the first method, we get 0.707. So this is standard deviation of the list. So what would be the mean value here? We can actually use, maybe I will first show you another approach to solve it. So we can use the statistics module to perform the same computation. Statistics, so we first import statistics. It's also a Python built-in module, so you don't even have to install it, I think. And then you call the stdef and you pass the list into it, right? And now we can print the same here, and we get like a different value because of Bessel's correction that I introduced in the beginning, right? Okay, then our third way to calculate the standard deviation is without external dependency. This is my favorite, although you shouldn't do it, you should rely on libraries. So first of all, let's have a look at the definition before. So we first of all need to calculate the average, right? This x with this x symbol with the head on top of it. So first of all, we need to calculate the average. So what is the average? So we simply use the built-in function sum, pass the list into it. So this sums over all values. So we get 1 plus 0 plus 1 plus 2, and then we divide by the number of elements. And note that both this value and this value are integer values, but this is not the integer division operator, it's a float division operator. Integer division would be like this double front slash operator, right? So the result will be a float value. So I can show you. So this is how we can calculate the average. You see the average is 1, right? Why this? Because 1 plus 1 plus 2 is 4, divided by 4 is 1. So the average is 1, and it's 1.0, so it's a float value. This is important. You should actually note those small differences. Okay, so let's go back to the definition. We sum over all data values and calculate the difference and square the difference from the data value to the mean value or to the average value, right? And then we normalize it afterwards. So how can we do this concisely? So basically we can calculate the variance first, and then the standard deviation would be the variance to the power of 0.5, because this is just a square root, right? So if you have the exponent 0.5, this would be like, this is per definition the square root. Okay, so now we only need to calculate the variance. And how can we do this? Basically we have a sum, and then we have a we divide by the number of data points. And we can apply Bessel's correction here by dividing by the number of data points minus 1, right? So we can use both approaches. Let's apply Bessel's correction. Now we only need to figure out the sum of the differences. How do we do this? We use a simple list comprehension statement. So we have some expression for x in list. So this expression will be a function of x. Yeah, right. So we use x to compute something, and we iterate over all values in our list. Now we need to find the difference between my x value and the average value that we have just computed, right? And we don't only want to calculate the difference. We want to actually square the difference. You see here the exponent is to the power of 2. So we let's close this. So basically we want to take this to the power of 2, right? So this is our expression. So we calculate the difference between two data points, between every single data points. We iterate over all elements in the list using list comprehension, and we sum over all these values in our sum function, and then we divide by the number of data points minus 1. This is Bessel's correction, and take the square root of the whole expression. And let's print the result. Now we can see it's the same as the second result, right? It's 0.81, and it's different to the NumPy result. Why? Because of Bessel's correction, right? So if we would take away this, now we can see it's the same as the NumPy result. So NumPy, our first approach, actually doesn't use Bessel's correction, whereas the second one, the statistics module, uses Bessel's correction. Okay, so I think that's it for today. It's a very quick video, but I wanted to just because like this is a very common interest, and I get a lot of questions because of one article I wrote. So I just thought this could be an interesting addition to the Thinkster tutorials. Thanks for watching this video. If you haven't already, subscribe to our Thinkster Computer Science Academy. It's an email academy. It's free for you. You can simply check it out and join our academy, join our email academy. So get the courses and the cheat sheets and everything, like the whole Python stuff, for free in your inbox. Thanks for watching the video, and see you in the next videos. Bye.